Hello and welcome to another video, this time going through Step 1 2008 Question 2. Yeah, these are great questions to practice if you're coming up to the mat and you've done all of the long questions on the past papers. Go to the oldish Step 1s like this and try some of those, particularly ones which look like they don't use any second year A-level mathematics. You can normally recognise them, but yeah, you know, you should be able to recognise which ones they are. I tell you what, you might not be aware of this site as well, the Step Database. Have you ever seen this website, Step Database? This has all of the questions from every step paper, and you can kind of look at it by topic. So, you know, functions is something which comes up a lot in the mat. Well, you know, let's try an S1 question on functions, a Step 1 question on functions, see what that's like. That looks much more like what you might find on a mat paper. Do you know what I mean? I'm trying to think of other topics which regularly come up. They like geometry and trigonometry. But remember, it's going to be kind of AS once again because they don't really test that. What else do they like in the mat? They like functions, they like that. I'm trying to think. Certainly there could be some calculus involved, and probably will be. But a lot of it will be, you know, this kind of stuff, you know, maybe. And you could use some of the Step 2s as well. There's no harm in that. But I'm just pointing out it's a good website. Okay, so anyway, this was a request from Ash. Brilliant. I love these requests. I really do. Very happy to have a go at it. I think what you've missed in this question, I don't know if I've got this right as well. Tell me if you think I've got this wrong, but I think what you've missed is, well, if you look at this little line here, it kind of sort of explains a bit more about what this question is about. You know, why are they saying b squared is less than c here? And maybe you saw this straight away, is to make sure that this quadratic doesn't ever turn negative, yeah? Because when does a positive x squared turn negative? It turns negative if it's got roots. Yeah, or what? If it's got one root, it doesn't turn negative, it gets to 0. But if it's got two real roots, it will be negative at some point, and this won't always hold. So the reason why they've set this as true is because if we wanted to make sure that it has no roots, because we need that, then the square root is square rootable. Make sure it's got no real roots, i.e. our b, which is 2b squared minus 4 times 1 times c, that's got to be less than 0, hasn't it? And that gives you 4b squared minus 4c is less than 0, and that's why b squared is less than c in this question. They're making sure that you're not a square root in the negative. Anyway, bear that in mind for later. And it's always useful to look at those things and ask yourself, why have I done that? Yeah, because it's possible to do this whole question and not actually, and kind of ignore that, but best not. Okay, so when I saw this and realised I've got to differentiate, I didn't want to make the differentiation too difficult for myself. So this is what I personally did. I took the x over there and squared both sides. And then I differentiated both sides with respect to x. In other words, I did implicit differentiation. Now that's fine on this side where you get 2x plus 2b. Here, I'm just going to use a bit of chain rule, and you can definitely use chain rule and implicit differentiation in one go. I'm going to differentiate inside the brackets, so I get dt by dx minus 1. And then I'm going to differentiate stuff squared, and that differentiates to 2 times the stuff. That's how I do kind of quick chain rule in my head. I hope you don't mind me using such casual language as differentiate stuff squared. It differentiates to 2 times stuff. We're differentiating stuff squared with respect to stuff, I guess you could say. Okay, so now then I just rearrange this into the answer. And it's definitely, I'm sure, possible to do this in a much more kind of longer way. And I reckon if I look at my old solution to this, I can't because it's at work at the moment, but I bet you I did it in a really kind of cumbersome and crude way. But now I prefer slightly faster approaches. Okay, that gives me x plus b over t minus x. And then I just added the 1 over. So dt by dx is going to be x plus b over t minus x plus t minus x over t minus x, and therefore you get t plus b on the top and t minus x on the bottom, and then I flipped it because I think they found dx by dt. Yeah, and it flips to the answer. So dx by dt is t minus x over t and b. Just check it. We're good, yeah? Okay. I did that, and I was all kind of like, you know, feeling pretty, pretty clever myself because that answer popped out straight away nicely. And then I got to this bit, and I was like, you know, because, you know, I tried plugging t back in here, and I was like, okay, x plus the root minus x. Well, that gives me a root on the top. And then I started realising, hang on, I want the dt by dx anyway, because maybe this is this, and integrates back to this. Basically, I spent a good 7 or 8 wasted minutes, and I think that's one of the things I like pointing out in these videos. Like, do not assume that this video is like a real-time, solving of my problem necessarily. Sometimes I do them in real time, but most of the time you're missing the 6 or 7 minutes at various stages where I've gone that's normal. It really is. I think it's normal. It's normal for me. I'm sure there are much cleverer people than I who don't do this, have this kind of moment where they're not quite sure what to do. But I do have those moments. Anyway, in the end, I looked at this and I thought, there must be it must be a hint here, and I thought maybe it's a substitution, and that's what it ended up solving it for me. I suddenly realised it's very easy to rearrange this. Yeah, if you're integrating 1 over root x squared plus 2bx plus c. Oh, I missed out the 2. Kept doing that in my working as well. That's poor. Okay, if you're integrating that, I suddenly thought, well, it's relatively easy to turn that into t minus x reciprocated, so 1 over t minus x in other words, and then I've already done the differentiation by substitution. So let t equal x plus root x squared plus 2bx plus c, and this is definitely not the only way to do it. I bet there's loads of equivalent methods. Then dt by dx, well, we'll just write dx by dt because we already know. Dx by dt is t minus x over t plus b. And so what have we got here? If we make the substitution, well, this is the same as t take away x and then reciprocate. So that's 1 over t minus x multiplied by, now I need to swap the dx for all of this times dt. So that's going to give me t minus x over t plus b times dt. Let me know in the comments if you had another way of doing it, and please let me know if it was a simpler way of doing it as well. But that's what I did. Okay, 1 over t plus b with respect to t. And so that's just a ln problem, isn't it? If t is a variable here because b is a constant. So you get ln of t plus b plus a constant k. Don't forget to switch it back out for x's because we were asked to integrate a function of x. What's t again? I think t was something to do with x plus that square root thing. And then we've got a plus a b plus a constant k. Okay, there we go. Now that is what that integrates to, I believe. Yeah. Now, verify by direct integration that your result holds also in the case where b squared equals c if x plus b is greater than 0, but that your result does not hold in the case b squared equals c if x plus b is less than 0. Yeah, interesting, very interesting. So, okay, I'm going to call this part 3. They never used to label them properly, especially in the old papers. It's like, well, with a bit of labelling, you can hopefully make it easier for the markers, surely. Okay, so anyway, part 3. Okay, so they're setting b squared equal to c now. Yeah, in other words, they're making this 0, aren't they? Like, they're not making it 0. They're giving it a repeated root. That's what they're doing. They're giving the quadratic a repeated root. So it now can actually equal, it can actually equal 0, which means you'll be square rooting 0, which seems reasonable enough. It's when you're squaring negatives that you can't do it. So I just went ahead and set it equal to this, because it said by direct integration. I thought it wants me to integrate it again. So x squared plus 2bx, and I'm going to swap c for b squared. Now, if you have done the bit in the Further Maths textbook where they start getting you to integrate things like this, you'll know that you always complete the square. But you don't need to, know that really to realise that this is a good idea, because look what you get. You get x plus b squared square rooted. Yeah. Now I know what you're thinking. You're thinking, I want to square root that square. Yeah. I totally get it. I definitely would have done it years ago. I did it actually when I did this problem, but I was acutely aware of this little known fact. I'd love to make a little course actually one day of little known facts which aren't understood necessarily by even the very best students at A level. Root of x squared is another name for mod x, yeah, and that's because root of x squared is not equal to x. Yeah, you might think it's equal to x, but it's not, is it? Because what about when x is minus 2? Square it, you get 4. Take the positive root of that, you get 2, yeah? Square root does not necessarily have... If we just write square root of 64, that does not mean 8 or minus 8. That just means 8. That means a positive root, yeah? And so square root of x squared is actually mod x. It's another way of writing mod x. And, you know, try it on GeoGebra or Desmos. I'm going to try it right now, actually. I don't know. I hope I'm right. I'm pretty sure I am. That if you type in y equals the square root, well, I'll put x squared, and then let's try this. Yeah, sure enough, if I type in y equals x squared all to the power of 0.5, it draws me the modulus graph, yeah? And that's because it is a mod of x. So you do have to be slightly careful here. You really do have to be slightly careful here. Okay, so this is the bit I haven't worked through yet, but this is the reason why it doesn't hold. And also, by the way, I looked at this and I understood what I was saying straight away here, just because if b squared equals c, it's possible for this to equal 0, yeah? And so if x plus b is negative, then you're going to be learning a negative number, and that's what makes no sense, yeah? If you see what I mean, that's the real problem here. We're going to be learning a negative number if x plus b is less than 0, because this basically is the same as like this, really. You end up with learn, but yeah, you're just basically dealing with a different case. Okay, so we're basically integrating now 1 over the mod of x plus b. Yeah, that's what we've really got here. Now, all that happens then is basically, let's draw a diagram. Like, let's try this. Okay, right. Now, if I was just going to draw y equals 1 over x plus b, yeah, what's that look like? Well, it'll have an asymptote at x equals minus b, because you always get them when you've got division by 0. It'll come down like that, where it will cross there at 1 over b, I think. And then it would go down like that, and that's normal y equals 1 over x plus b. Well, when you do the mod of that, it just goes on up here, yeah? And I do understand what you were talking about here, Ash, saying, oh, you know, surely it works for when it's less than b as well as greater than b, because you're saying this has an area, yeah? And it does, you're right, it does have an area, it really does. I think it's handy in these kind of situations to say, let's assume x is greater than b, yeah? Oh, sorry, yeah, which is the same as saying x. Ooh, no, let's be careful. If x is greater than b, yeah, let's assume, sorry, x is greater than minus b, because that's equivalent to x plus b is greater than 0. So let me just change it. Assume x is greater than minus b. So I'm just going to take the case where the limits, yeah, if you like, if you're working out a proper area, yeah, and it didn't ask us to actually do it with any limits, did it? We just we verify by direct integration. Good. We're looking at this. I'm going to draw a diagram basically and make my argument here. I hope it makes sense. Like I said, I haven't actually looked at the mark scheme or anything here. These are just my thoughts for you. Hopefully it sort of illuminates things a little bit more. I hope they're right. But yeah, if this is the case, yeah, and it will verify that this result holds, yeah, because we're going to verify by direct integration that our previous result holds, yeah. Okay, assume x is greater than minus b, then we're simply integrating 1 over x plus b, yeah, dx. Okay, well that is the same as ln of x plus b plus a constant c, yeah, and that looks absolutely fine since x plus b is greater than 0. We are fine, yeah. But on the other hand, which I think they normally abbreviate to OTOH in STEP, yeah, they do that in the mark schemes anyway sometimes. So on the other hand, if x is less than minus b, and if x equals minus b, by the way, you've got ln of 0, so that's no good, and also x can't equal minus b because the curve's not defined for when x is minus b. Okay, if x is less than minus b, then what are we really integrating? We're really integrating minus 1 over x plus b, yeah? That's just to make sure I flipped that, you know, which was down here in the x-axis to put it up there. I've changed the y coordinates from negative to positive. Okay, with respect to x, yeah? Now this is going to give us minus ln, sorry, of x plus b, yeah? But remember that x plus a constant c, you know, but x plus b is less than 0, and hence this has no meaning because you're going to end up with a negative value which are lunning. Yeah, that's the problem. Now I suppose you could argue, oh hang on, what about luns? These should always be modulus after the integral. Is that what they're getting at in this question? Yeah, maybe that's what they're getting at, in which case it's fine. I think the area does exist. The modulus with the lun just occurred to me, by the way, literally as I'm doing this video. It's like, oh yes, that actually is a problem. So let's just have a little look, but that the result does not hold. I guess we're actually testing though. What result are we testing? Yeah, we're verifying by direct integration that this previous result holds when this is true, but this previous result does not hold when that's true. Yeah, so I should be looking at this result, sorry. I think you're right that you can work out the area to the left when x is minus b by doing minus ln of x plus b, because you've carefully handled it. But if you look at our result here, yeah, if b squared equals c, what was it, b squared equals c, I think it was, yeah. b squared equals c, then what do we have here? We've got ln of x plus root of, right, if you've got that, you've actually got here 2bx plus b squared, and so that's the same as x plus b squared again, isn't it, square rooted, and then plus b, okay, plus the constant k, that's the same as ln of mod of x plus b, but then we've got this x plus b loose, not in the mod, yeah? And this is our problem, yeah? Because as x plus b is less than 0, you're just going to end up doing ln of 0 there, because like you'll have basically, like, let's say x plus b is minus 5, then the mod of x plus b will be 5, and you'll end up with ln of 0. So I think it's because you're verifying this result, yeah, not this result. I'll tell you how I'd normally check my answers here as well, Ash, because I don't know if you're aware of this website, and they're really useful websites. There's an old, somebody wrote answers to these on MEI. Let's quickly check it. MEI Step Solutions. Careful when you type MEI. This was it's an exam board, but it seems to always bring up Mein Kampf as if you're some kind of a, you know, admirer of Hitler. But anyway, right, where were it? MEI Step Solutions. Work Step Solutions. It will be. Might just be on this front page. You have to scroll down a bit. They've hidden it. It's like a needle in a haystack, this, but well worth being aware of. No resource selected. Okay. Okay, I might have to try the evil Google. MEI Step Solutions. Something Solutions. Okay. Yeah, right, now, amongst the 15,000 things, look for a popular one. It's always popular because lots of people use it. Somebody basically wrote down loads of step solutions. I really like the person who did them, actually. If I've just gone past them, look, there they are. Okay, right, you've got lots of the old solutions here. They're work solutions. Just access a guest. Let's see what, let's see if we're right. Yeah, I think it's because we're testing the result that we proved, you know, we're testing that result by direct integration, because I think you're right that you do have an area there. It will be in here, I guess. 2008, question 2, magic. Okay, right, let's see what this person's done. See, they've differentiated in a different way. I quite like my way, to be honest, but there we go, it's not too difficult. Okay, yep, so we got that right, that's good, plus a constant. Okay, let's set it to that. Okay, yeah, look, they've been careful, they've said it equals like that, just like I said, because it's a modulus, basically. Now, they've had to be careful. Oh, and they've split their luns. Now, why would they do that? Let me just check I understand this. How the two cases correspond to the above result. Yeah, they're comparing it to this result. Give this. Yeah, I think he's essentially arguing exactly the same, or she's essentially arguing exactly the same as me. I'll check this, so I'll have a bit more of a careful look. But my thinking is, basically, it's not that you can't find the area to the left of that, because it's perfectly symmetrical, that, you know, that graph. And yeah, you can definitely find the area, and if you integrate it carefully, you can do that. But with your initial you know, your result from integrating this holds if that's true, but it definitely doesn't hold if this is true, because you end up with ln of 0 when x plus b is less than 0, and that doesn't make any sense. But yeah, hope that was useful. I hope that website I showed you, or some of those, they might be useful to you if you haven't seen them before. But yeah, best of luck with the map. Bye bye.